board on this computer. Okay, so you will join the Zoom lecture for a final exam, right? Find it the same way everybody else does, which is I go academic calendar temple, final exams, and then click on the link. Then I click on this for spring, and then we're under 3 credit course hours because that's what our time matches. Because again, we're a 3 lecture hour course, but a 1 lab hour. So for a total of 4 hours. Doesn't make sense, but okay, this is what I go with because none of the other times make sense. 2 to 3:20, Tuesday, Thursday class. So we're doing Thursday at 4:29 from 1 to 3. You will jump on this on the link on Zoom. If you have a exam on the same day, of course, I have more than one. If you have multiple exams on the same day, of course, I will willing to basically talk to you about any kind of accommodations, taking it earlier or later. Again, today is going to be devoted towards reviewing towards the final exam, as well as that. So I'm going to go ahead and show you one of the questions I need to replace. I've shown it already, but I'm going to show it again just to let you know. It will be each problem. You have 3 problems. Each problem is broken up into multiple parts. Each part is graded independent. I try to grade as independently of each other, of each subpart. I try to grade as independently as possible to maximize points, and I try to give partial credit for those things. So I don't really care so much if your program doesn't. It's less about does your program run, because if you miss a colon and that forgets how to run it, or the indentations, like, that's one thing. I recommend writing the programs in VS Code and then just copying it into Canvas. So just copy pasting it in. Okay. So, and then I think I'm going to have a 4th 0-point question where you can just upload your code so that you have a backup. Are you allowed to open notes? So let me go ahead and show you the prompt that you're going to get on this. This is just like a quiz, except that you're going to be all the same. Yes, you can use anything you want. You can write an idle, whatever you want. Okay, let's go to canvas.temple.edu, canvas.temple. So come the appointed hour, makes it sound so biblical, right? Come the appointed hour of the at 1 o'clock on the 29th. Yeah. You will go to the final exam module or under to quizzes, either of those, and you'll be able to find the final exam here, which I still have to publish and change the date. This is the one from last semester. So let's go ahead and see and pull it up. This is what we will see here, and we can see the first question here. I'm going to leave it on the screen for a second while I let my puppy upstairs so that you can just kind of see, and we'll take a look at the first question from last year's final. Hi, puppy. Coming to say hi to the class? No, you're just coming to just look for crumbs? Okay. Okay, so here, exam is open note, book, internet, computer, etc., with the following caveats. So basically, do not communicate I should put this first. Do not communicate with anyone during the exam. Your work should be your own. Basically, you can use any resource you want so long as the resource you're using is not direct access to other people. What does that mean? That means apart from me or a TA, don't directly ask questions for anyone. That includes don't post questions on a forum or on like Chegg or Homework Helper or one of the amazing other sites. I'm really good at finding that stuff. Like, so, like, I like, especially, it really also annoys me when I see my problems dropped on those sites, because I put effort into these and then I can't reuse them. And that's a pain. That really is a pain. And also, like, a lot of times the answer is incorrect. And also, if it is correct and you're posting it, it's not always, you're not the only one who sees that, really. So somebody else is going to turn in the exact same answer as you, and that's how I catch you. It's really easy. Yeah, you can look at a code example or a site like Core or Stack Overflow. So, so one of the problems you're going to have is going to be analyzing a board game. Yes, I did make the problems. So one of the problems you're going to have is going to be about a board game. I'll get into that in a bit more detail. But what a bunch of people did last semester, which earned them an instant 0 on the exam, on the final exam, not a pretty process, was that they decided to they decided to Google for the board game's code. Like they looked for Monte Carlo for this board game name, and they found a link. But it was for a different version of the board game. And they didn't cite it. So, and as I posted in my syllabus, one of the ways to really make me angry is to copy paste code and not realize what it's doing. So don't just if you're going to go and use the internet for a resource, don't just blindly copy paste something. Make sure that you're actually looking for something that's, relevant to the problem you're trying to solve. Because just throwing in things like random, it's not going to do, right? I can also tell because there's a couple things I explicitly don't teach in this class, like list comprehensions. I do not teach list comprehensions because a lot of Python programmers love to use it. And so when I see that in uncited code, I'm like, ha.
So what if we're guaranteed, say, like a 60? In other words, we get 2 questions out of the 3, right? Or whatever your grading system is. And then we go to your video, not during the test, but like
the videos, you can use the video during the test. That's fine.
Yeah, but say I put I'm really worried about this board game problem. So if I just put scraps of parts of the problem and that may or may not make sense, is that willing to get like a partial?
No, it's the lack of citation. It's the plagiarism that gets me. It's the fact that you go out and grab something and say, this is my work. I made this, and you didn't. Does that make sense? And also because, and literally it was 10 students who turned in the exact same code.
Yeah, that makes sense.
Comments, you cite by commenting.
Mm-hmm.
And the other big thing is to know, like, basically actually read the code you're grabbing, or read, if you're grabbing and citing code, read it and make sure how to say, it was like, basically, I was saying, it wasn't tic-tac-toe, but I was saying, here's tic-tac-toe. Please do some code to analyze tic-tac-toe. Exactly, Stephen. And I said, please, do this tic-tac-toe. And people went and searched to the code, and the code they had was for 4 in a row tic-tac-toe, for a 4x4 board instead of a normal 3x3 board. Make sense? That was where the students messed up. Basically, it was for a completely different version of the game. So none of the answers they gave made sense. Does that make sense to everybody?
Yep.
So you said the board game was going to be the question was going to be about analyzing the board game.
Yeah, I'm gonna. It's the board game you're gonna play is basically asking how often. It's a cooperative board game, and I'm gonna be asking you, since it's completely dice roll based, how often are the players gonna win?
So like kind of the odds of each side.
Okay. That's what Monte Carlo is.
Okay.
So should you comment to a line of code and explain what it's doing? Ideally, that's what I like. But when in doubt, just simply comment. If you need to grab something from the internet, you're like, oh, that's, and you can't rewrite it yourself because for some reason you don't know how, which you should know how to do, then just cite it. Just cite it. Okay. So let's go through these in a bit more detail. So feel free to use any programming environment such as idle or PyCharm to write your code. You will answer with code. What are the resources to practice the exam? I've kind of mentioned I tell you what the problems are, or I tell you what the problems are similar to, and I've been telling you for a while, but I'm going to go over again. Okay, so you can use anything to write your code. Do not communicate with anyone else during your exam. Your word should be. If I find your questions posted on the internet and your answers I sourced from there, you'll receive a 0. That's again regarding Chegg and Homework Helper or other sources of just general like stuff that students use, just those giant plagiarism resource websites. You're going to be on Zoom, so you can ideally you're on Zoom, so you can ask me questions if you have questions. That's why we're on Zoom together. It's not so I can really proctor you in the sense to make sure that you're not cheating, because that's impossible if with 120 students, if I can't get you into the same room at the same time. And I would rather, I don't like the software they have, and I don't like the idea of having false positives for my students. Okay. But this is basically saying, don't post our stuff to Chegg. You will get in super trouble for that. Be sure to use the pre-formatted setting for the text box in each question. You can find the next, and the real reason I don't want you to cheat, by the way, on a personal reason I don't want you to cheat, is that it's a pain to do the paperwork. It really is. Yeah, we're not doing proctorial. It's dumb. So literally we're on the Zoom session so you can ask me questions. That's really the only reason. Or if there's ambiguity, I can address it. So be sure to use the preformatted setting to a text box for each question. I'll show you what I mean about that. It's going to enable you to do monospacing. And do not use the input function inside of functions unless you're using points. You use your if you're writing a function, don't use an input inside of it. Get the data from the parameters, okay? You shouldn't ask anything. You shouldn't necessarily like ask for input from the user. Finally, the exam is 2 hours long. It is from 1 to 3. However, I am perfectly aware that people may need more time. Okay. That happens. So unless you have an accommodation, there is a late penalty for you to get extra time, which is 0.1 point per minute, which is actually really lenient if you think about it. That's 6 points every 10, sorry, that's a point every 10 minutes. So that's 6 points an hour. So, and this is just simply, okay, if I need some more time, this is just simply exists. So if you really need some more time, you can take it, but it's not necessarily, but it's, not unfair to the people who don't take the extra time, because there needs to be some penalty. I have to have some penalty written down so that you can't turn it in, 2 days later. It does, so if you really do stress out, take your time. It's fine. An extra 2 hours still means a B. It's perfectly fine. If stuff does happen, like your internet goes down, just like email me with a message or something. Okay. So let's take a look at the problem we had from last semester, the first problem we had from last semester. Okay. So the first problem we had from last semester was 30 points. And we see that it's fairly actually, it's written fairly straightforward in a fairly straightforward manner. So let's see. Sorry, I'm trying to click on these links over here. Here we go. Cancel. Okay. Write a script or a function that, given a file name, reads in the contents of the file and creates a new file. So you should expect basically that, well, there's only 3 problems. So, and I pretty much spell it out. So basically, you're going to basically get the same prompt, right? A script or a function that, given a file name, reads the contents of a file and does something, creates a new file with, and the something is here is changing. So last year it was all TU email addresses removed or censored. A TU email is an email like mine, tug8561@temple.edu, right? So TU emails are those that start with a T, a U, then followed by another letter, then 5 digits, and then @temple.edu, right? I've gone over this in class before. It's okay if you missed it. And I said, and I gave, here's an input file. If I give you this file, then this is what we should get. Notice that my Gmail and my alias temple email are not redacted, but this email and these random emails I grabbed are redacted. So I give you basically an input to say, this is for you to test that your code works. And this is right. I don't care that, excuse me, I'm having a nosebleed and that is mildly embarrassing and inconvenient. 1 second. Oh, man. All right. Sorry about that. I am super glad, by the way, that this is not a horror movie because like in movies, like if you get a nosebleed, that means like you just caught this super disease and are about to croak. So, you know, but it's like been super dry, hasn't it? All right. Final project, yes, is due Monday. Turn in what you have, even if it isn't complete, because again, we are so totally more interested in the journey rather than the destination. We prefer the journey over your destination. If you're unable to complete it, please let us know why. And by the way, please let us, I didn't realize the progress reports weren't open, so please submit those as soon as possible to give us expectations. Yep, we're all done after this week. If for some reason like something explodes, let me know, okay? All right, so let's get back to this. So again, you'll be given a question for this that is something like this. Here it was read all email, get all emails in a file like this and redact all the information that I specifically want you to. So this is so given a text file, please parse it and go through it and deal with some and do something for it. Okay. It will be something along now. It's the kind of thing that will take about 7 lines, 7, 8, 9, 10 a line of code to do if you can do your regular expressions, depending on how concise you are. So if you've learned your regular expressions, great. You can do it without regular expressions. It's just a bit of a pain to do it without it. Okay. Now, the what could you expect to see on the final exam as opposed to doing these as opposed to like emails? Because obviously I'm not going to reuse this. I might do some other email address rather than Temple. I'm with like some other kind of weird thing, right? I might do something like social security numbers, right? Or Pennsylvania Pennsylvania driver's license numbers, something like that, where you have something specific that I need you, some specific sequence that I want you to censor because, you know, some information we shouldn't see like, you know, social security numbers come to mind, you know? So basically coming up with some kind of regular expression, and regular expressions will be able to solve the problem. Now, how do you get points on this one? Yeah, the problem will be different, but the concept is going to be exactly the same. Given a file with personal information on it of some specific type, I want you to remove that information. Okay. Yep. And you can download it by just hitting Control S or Command S to save this. Or you can just copy and paste it into a new file. Or you can just like right click and save as if you're there. So, but the point being is that you're given a text file and your web browser might interpret it differently. Okay. We're just going over the exam questions today. Yes. Or different concepts for the exam. So now let's look, notice that it's worth 30 points and I break it down over here. All the questions are going to be broken down in a similar manner. So this one's broken down 5 points for reading the file. For instance, this is basically, you get 5 points for knowing how to do an open statement and a read statement, or a read line statement, or a four line and file statement, right? 10 points for being able to write code that identifies the TU emails and only TU emails. If you overshoot and I basically get all email addresses, then that's going to be a couple points off, but you're still going to get the bulk of the points because you are still doing most of the work. You're just being over aggressive for it. 5 points for being able to create a new file and basically load it with the information. And then 10 more points for removing or redacting the files, right? Or removing or redacting information. So it's broken up into those kind of things and you can tackle them one at a time. And again, partial credit is available for each of those. All right. So what is problem 2 going to be? Problem 2 is going to be along the lines of, here is a thing built into Python. Python has a lot of built-in things. Python documentation. Right, so let's look at the Python documentation, right? There are a bunch of library reference, global module index, and of course, built-in functions, right? There's all these kind of functions that do stuff here. So I'm going to plan on giving you something that's in here in the standard library, like something that we haven't necessarily gone over yet. Okay, so one of these types maybe, look, oh, there's a type for complex numbers, right? Which seems useful because, you know, it handles all having to deal with complex numbers, so you don't have to figure out how to do that, right? Complex numbers are a pain. Let the computer do it, right? But I'll give you a type, right? Or something that you haven't, or a function you haven't seen before, and I'll say this is what it's used for. And here's what the problems it's used for. Here's a problem that you can use it on. Please do it. So basically, that one is specifically going to be testing your ability to go over new information and use it. Okay, which is basically one of the big things that you need to be able to do if you want to do programming, or if you want to basically utilize your programming. And again, it's not terrible. Like, it is going to be, the function and the thing you do is a very simple concept. There might be advanced mathematics behind it, but the concept of what you need but utilizing it in a practical manner is actually going to be extremely simple. Okay. And then finally, question 3 is going to be a Monte Carlo problem. So that will be something along the lines, and let me pull up something from a previous exam. Again, different exam one. This one is from the before times when we were meeting in person. Moment of silence for the before times. Okay, so let's go ahead, and I know I got to share my screen again. Okay, so exam 2. All right, and again, I've showed this one in class before. All right, so sorry about this. Give me 1 second to make sure that I've got it a good. So here in here I basically said, here, do a Monte Carlo approximation of Monopoly, right? Which is basically roll the dice. Sometimes when you roll the dice, there are conditions where you get an extra turn. How often do you get extra turns, and how often those extra turns land you in jail? Because if you get extra turns 3 times in a row, you go to jail for quote unquote speeding. So basically this one was simulate 100,000 dice rolls, handle the doubles, handling 2 to 3 doubles in a row, and presenting the data in percentages. So this one was a fairly straightforward one to do. You know, analyzing something like, okay, what might be another one? Well, let's look at this. Why don't we try a question that I'm just thinking of right now? Okay, I'm going to go ahead and boot up VS Code of something along the lines. This will definitely use the concepts from Pig Lab, but it's definitely going to be a bit more less time consuming. So let's go over something fairly simple, which I think would be appropriate to do. I might add some difficulty to it if I was giving it an exam question, but let's do a Monte Carlo on Blackjack. Okay. Okay, and for this one specifically, I want to know one thing, which is, so let's go ahead and assume this would be the question for the final exam for that one. Okay. Let's say that basically I want to know how often the player gets a blackjack. Now, what is a blackjack in Blackjack? So first off, what the heck is Blackjack for those of us who don't know? Blackjack is a game played with a standard deck of 52 playing cards. Note, so in other words, we know that Joker nonsense or anything. The goal of Blackjack is to create a hand via various steps that gets you a grand total of 20, as close to 21 without going over. So you want to get to 21 without going over. Let me go ahead and point the camera a bit more down, right? So that you can kind of see my screen. No, that's not working. I want to, oh, right. I need to pin my window, I think. Pin me, spotlight for everyone. Okay. And then let me stop sharing for a second. Okay. So here we go, right? We've got a full deck of playing cards over here. So the way Blackjack works, and I would explain this in written rules, but Blackjack, for those of you who don't, and I'm not going to assume that the game we're playing is something you're going to know the rules of, right? So so basically the way Blackjack works is that each player gets 2 cards. I'm just going to do it with me because simplicity's sake. So here we create a hand, and this hand is worth 20 points. Face cards are each worth 10 points. Let's try a different hand, right? Okay. 8 and 6. Okay. That would be a total of 14 points. Now, the way Blackjack works, to oversimplify the rules, is that basically I have 2 choices. There's other choices I can make, but for purposes of Blackjack, for this, there's 2 choices I can make here, which is that I can either hit or stay. If I hit, that means I'm going to ask for another card. I can do that as many times as I want, as so long as I don't go over 21. Or I can stay, which means I basically say that's my score for the turn. The player with the highest, if you beat the dealer, you win. So I would say hit in this case, and because I got over 21, I lose. Okay, the dealer has very specific strategies that they need to play with, but otherwise that's how it works. So, okay, okay, so now let me go back to sharing my screen. So what I'm interested in is how often does the person get a blackjack, which is aces have a special value in blackjack. An ace can either be a 1 or an 11, whichever is more advantageous. So, okay, so the first thing we need to do is create a deck of cards. Okay. So we need to make a deck of cards to figure this out. So first thing we need to do is that we need to put in, so first off, what is the deck going to have? It's going to have all the numbers between 1, and then, so we've got all the numbered cards. 1, so we've got ace, 2, 3, 4, 5, 6, 7, 8, 9, right? And then we have 10, of course. So we have 1 through 10. So there's 4 suits in a deck of cards, right? Each suit, so that's basically the color and shape combination. Each suit has ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then they have the jack, king, queen, and the jack, the king, and the jack, the queen, and the king. Okay, so for a suit, we can just simply say, hey, so for blackjack, we don't care what the suit is. So we'll just keep track of the card values numerically. We'll say, hey, 1, 2, 10. Okay, and then let's turn that into a list. Okay, and now, so that's just going to be the numbered cards. Okay, and now how am I going to do this for my, now here's the next question. What do I do for my cards that are the king, the queen, and the jack? Well, they're all worth 10 points. So I'll just simply add 10, 10, and 10. So if I print out my deck at this point, remember, if you do addition with lists, it concatenates them just like you would a string. So we've got all the cards through the 10, and then we have the face cards. Make sense? A question for blackjack players. For a blackjack, does it have to be a face card? Is it still 21 if you do ace and a 10? Okay, great. Just want to make sure. That makes things, I was going to say that's how it's going to work here, just to make simple things simpler, but good. So we have a single suit now, but we need 4 suits of cards because there's going to be 52 cards. So what I'm going to do is I'm just going to simply take this, and remember what you can do. If you multiply a list by a number, it simply replicates the list. So print. And so there we've got our list. It is one, it's got one suit, then the next suit, then the next suit. And again, we don't care which is which at this point because we just care about the numbers, right? We don't care about the actual suit. So I'm not going to bother keeping track of it. So, okay. Now if I'm going to actually play this. So first off, let's go ahead and double check to make sure that we've got all the cards we need. How big is our deck? We need 52 cards. Just kind of sanity checking here. 52, great. Okay, next we need to shuffle this deck because right now it's, not that great. So deck dot. So we're going to do import random. And I'm going to say, and again, this is taking a lot longer because I'm explaining the rules and I'm explaining what I'm doing as I'm doing it. Which really takes a long time. So import random. So we've got our deck. And now what I'm going to do is that our deck needs to be shuffled, right? Because we need to make sure that we are going to randomly generate our deck. So fortunately, random, right? If we look, and if we didn't know how to do it, if you looked up, how do you shuffle a deck in Python? It will probably point you to random.shuffle. Oh, look at that. See? Shuffles a list in place. So that means all I have to do is say, hey, shuffle the deck, and I can print it again, and it's going to be it's going to be randomized for us. Isn't that magic? Right? 3, 1, 2, 3. Okay, excellent. It's been randomized. Okay, so how do I draw 2 cards? Okay. I'm going to draw the 2 cards by basically saying, I'm going to draw the 2 cards by saying, by basically just simply grabbing the first 2 cards off of it. So the first 2 cards off the deck are going to be me drawing the 2 cards. So here we got a 10 and a 7. Here we're dealt a 14. Here we're dealt a 4 and an 8. So we want to know how often does this blackjack occur? Okay, so let's go ahead and turn this into a function. Def deal hand. Boom. Okay, we're going to generate a random deck each time. I don't really care that yeah, it seems a bit wasteful, but whatever. It's a way to do that. And then I'll just simply return the first 2 cards. Right, so, and this only really, if I was doing more than one player, I would probably have to rewrite this. But for just dealing with the one player and saying, how often do I get dealt 2 cards? This works. If I want to, deal this with a dealer, I might do something else, but this will be fine, dealing the hand like this. So for, so we're going to do this, trials is equal to, let's do it 100,000 times, right? Say I want to say I'm asking you with the Monte Carlo question, if we were to draw, if you were to be dealt 100,000 hands, how many of them would be blackjacks? So, or what percentage of them would be a blackjack? So trials for blank in range 100,000. That means that whatever goes in here will be done 100,000 times, except that we've got a nice value that I can use trials. So I don't have to count to make sure I've got the right number of zeros. I just had to do it once. So for blank in range. Okay, what I'm going to do is I'm going to say my hand is equal to deal hand. Okay, that's going to get me the first 2 cards. And then I've got to ask myself, did I win or did I get a blackjack? If hand, so it's got to have a 1 and a 10 in it to get a blackjack, because the 1 can also be turned into an 11, right? If it's an ace, it can be turned into 11. So if, and their numbers. So if 1 in hand and 10 in hand, doesn't matter where they are, then wins is equal to 0. Okay. And now wins plus equals 1. If that's correct. Otherwise, just keep going. Print wins divided by trials. Boom, run. And it says that, hey, around 5% of the time, I'm going to win outright, which is pretty good. That's like rolling a 20 on a natural 20 on in Dungeons and Dragons. About the same odds. Right? 0.4, about 4 to 5% of the time, I'm getting a 1 and a card that's valued 10. So that will that will be about 20 points. Oh, sorry, that will be 21 points. So let's go ahead and so that could be an example of the kind of problem you might see for this. The problem I have in mind is has a bit more moving parts involved, but okay. Give me 1 second. I'm going to go and get something that's a bit more realistic to what we are looking for. Okay. Is the box game upstairs? It is up here, I'm sure. Ah, here you are. Board game. Outfoxed. Look how friendly and cute it is. It's a wonderful game. Outfoxed. Okay. It's a cooperative whodunit game. The object of the game is fairly straightforward. Okay. Which is basically, it's a kind of collaborative whodunit game. You have pieces on the board and you roll dice. And the actual mechanics don't really matter for the purposes of this game, but we've got this board here and we've got this path. Okay, and the idea is to find out who the fox is before he escapes. And the fox starts out on this square. And then as the players have a misfire, so to speak, he runs away until he gets to this space over here. Make sense? So you've got this space, and you got this space over here. So he tries to go down these spaces. Okay. So when does a fox move? Right? When does the fox? So when do people have issues with moving? The issue you're having with the plus is that the range has to be in a list. You can't add a range, you have to turn it into a list. So the way this works, the fox moves, is that the fox will move 3 spaces if the players don't get a match on the dice. Okay. So how does the dice roll how does the dice roll in this game work? Well, it uses special die. It uses special dice. Okay, let's take a look at, you've got 3 dice, and 3 of the dices have an I on it. I, and I. 2 of the dice have a single paw print on it, and 1 has 2 paw prints on it. And what the player does is that before he rolls, he says, hey, I'd like to look for clues, or I'd like to look for clues, or I would like to I'd like to look for suspects. If you look for suspects, you're trying to get the eyes. If you're looking for clues, you're trying to get the paws. They're equally likely, and what you do is you roll it. And look, I got 3 eyes, so that's a good, so the fox doesn't move that turn. However, if you get a mismatch like this, like here I got an eye, and a paw, then what happens is that I can lock the 2 that I rolled, and basically I can re-roll the ones that I didn't want. And I can do that for grand total, so I can roll a grand total of 3 times. So it's a paw again. Oh, 3rd time it's a paw, so all 3 of them don't match. So the fox moves forward 3 spaces. Everybody understand? So when it's a player's turn, here's what they do. Let's go ahead and compute some statistics on this, on the player rolling the dice. The player has these dice over here, right? I want them to match up. I get 3 chances to match them up. So I roll all 3. If any of them are the result I want, I lock them, and then I have up to 3 chances. Yes, it's kind of like Yahtzee to roll. I just keep trying to roll and roll again. So what I want to go over is, well, wait a second. How in the world do these aren't normal dice, right? To do a dice, we've been saying, give me a random number between 1 and 6. What the heck do I do here? I'm so lost. Well, never you worry. That's why we're here today. All right. Yahtzee's a dice game. But the idea here is that we we get 3 chances to re-roll our dice if they're not in the result we want. So let's go ahead and say, I'd like to find out how often the player doesn't get what he wants, right? How often do I not get, do my things not, how often do I fail and the fox has to move? Okay, so let's go ahead and define a outfox die. A die is equal to well, what I'm going to do is I'm going to define all 6 of the sides in a list. So we had 3 eyes. So I'm going to say, and rather than being clever, I'm going to go ahead and write it out. So I, comma, I. So we have 3 eyes. When we have a paw, and then we have 2 paws on one side. The advantage of that is that basically if you get 2 paws, you can when you're looking for clues, you can move an extra space. So that's nice. Okay, so you've got an eye, and an eye, and paw. Okay. So statistically, it's more like I, and miss. But that's fine. So that's what our die looks like. Okay. So let's go ahead and see what, so we've got our die, and we're going to need 3 of them. So I'm going to go ahead and say D1. I'm going to say die 1, die 2, and die 3 are they are the same. Makes sense because we have 3 dice. Because I need to roll these suckers independently of each other. So what I'm going to need to do now is say, you know what, I'm going to eliminate the double pause right now because it doesn't really matter for the purposes of counting our statistics at the moment. Okay, so we have eyes and we have paws. Okay, so how does this work? How do I roll this dice? So basically, well, let's make a function to roll the dice. Let's go ahead and put these dice in it. Def roll. So die 1 is I, die 2 is I, and die 3. So we have die 1, die 2, and die 3. Okay. I don't actually have to make 3 dice. It's just it's much more easy if I do it this way. So I'm going to say, R1, and I'm going to say our result. Actually, yeah, I'm just going to use 1 die. It makes it easy, and I'm just going to roll it multiple times. Does that make sense? Okay. So, I mean, I don't know actually what the best way to do it is, but let's go ahead. So what we need to do is basically we need to roll the die. So first off, how do I roll the die? The way I roll a die is I again use the random function, but I'm going to use something called random.choice, which simply selects one of the things that element, one of the things from inside here at random, right? If it was, so for instance, let's go here to the terminal for a second, right? This is really cool. I just simply said I just simply copied that into the terminal with a keystroke. So if I say random.choice die, I'm down here in the terminal. Oh, I have to import random, of course, first. Import random die dot choice. So random dot choice die, and it will give me an eye, a paw, an eye, paw. So it's randomly going to choose between those. Okay, cool. All right. So what I'm going to do is basically say I'm going to have 3 rolls. Okay, so I think I know what I'm going to do. I am going to basically say, yeah, okay. So I'm going to simulate it fine. I'm going to go overcomplicated on this and simulate, and I'm going to have 3 dice. Okay. Die 1, die 2, die 3. Okay. So what I have to do is I have to roll the 3 dice. So, so my result is equal to, so I'm going to say R1 is equal to die 1 dot, sorry, random dot choice die 1. So that's our rolling the die 1, rolling die 2, rolling die 3, 3, 2, 2, 3. All right. And so basically, let's go. It can be definitely want to use this as a list. Dictionary kind of wouldn't make sense for this because of the repeats and stuff. So die 1, die 2, because we really don't have key value pairs here. So let's, for the sake of assumption, say eyes are good and paws are not good because I'm trying to go for eyes. They're statistically equivalent. Okay. So I'm looking for suspect using the eye. So I want to roll 3 eyes. So basically I want to say, so I'm going to go ahead and put all these into a list. Results are equal to R1, comma R2, comma R3. So I put them all into a list. So I can ask myself, if paw in list, right? So if the paw is in our result, so if we've got a paw in our results, that means we didn't succeed. So actually what I can say is if not paw in results, return true. We did a good turn. Otherwise, what am I going to do? I am going to have to re-roll. But what do I have to re-roll? So I'll do it, you know what? And I'm not going to try to be elegant or anything. I'm just going to go forward and say, hey, if R1 equals a paw. So if R1 is equal to a paw, then we're going to re-roll it. Right? Because you get to re-roll things. You can get to roll things up to 3 times. If R1 is a paw, and then we just do this for R2 and R3 because it's going to make it, no, that's not what I wanted. R2. And then I just simply, actually, I don't need the else here because the return true kind of obviated that. Okay. One, two. Yep. So what we can do here is that we can, so we've rolled it once, and if we didn't get, and if we got only eyes, there's not going to be a paw, so return true. Otherwise, well, at least one of these things was a paw, so we're going to re-roll anything that was a paw. Okay, and then we're going to put it back together again. And then we're going to do it one more time. So we'll re-roll it. So check. The result of our re-roll? Did we re-roll it and we get a paw? if we re-rolled it, we got our second paw. No, the specific example won't be on the exam, but it's useful to know how to make random just dice, arbitrary dice of anything. If paw is not in the result, return true. Otherwise, re-roll these things if they're paws and get our final results. And then finally, one more time, check to see if you've got your results. Did we finally get a match? If so, yes. Otherwise, return false. We could have probably been a lot more better with this, but with some for loops. But basically what we did, because we didn't use any for loops or while loops, what we did is we simply said, hey, here's our 3 random dice. Let's roll them and then copy paste a bunch. Because that's what I would expect for brute force. So let's go ahead and see. So let's go ahead and see what the statistics are. Trials is equal to 0. Wins equals to 0. Right, trials it should equal to some good high number. 4 blank in range trials. So do this trials number of times, right? Now, what we're going to do is we're going to say roll. That's going to give us a true or false. So if roll, if we win, then wins plus equals 1. And then print wins divided by trials. So 67% of the time, in other words, around 2/3 of the time, the players are going to be, because of the way you're re-rolling, the player is going to be able to get a match of 3. Okay, so that's what the statistics are on that. So that would be an example of a kind of question I would ask on the exam. What if I wanted to add the extra layer of difficulty is I'd ask how many turns on average does it take for the fox to get to the end, right? And then we'd have to count, and then you could just basically simulate that to see how many turns. But this kind of dice rolling question where you've got basically custom die that we're rolling and trying to figure out statistics on and how they affect the game, that would be the kind of question that I'm a big fan of. So you have 3 questions. Now the rules for each of these things aren't actually going to be all that complex. I've made sure to choose very simple games that are very simple to analyze, or at least the rules are very simple to understand, I should say, but not like, but it's not going to be like figuring out checkers or something like this. Again, I've told you that it's going to be a dice roll, that the game is going to involve, that the progress through the game is all dependent on the luck of the dice. So it's going to be a dice rolling game. And since you're clever people, and I kind of just went over an example that used a custom dice that I had to create myself rather than a normal 6-sided die. It was still 6-sided, but it had custom faces rather than your standard die that had the numbers 1 through 6. Instead, I went over an example that had I and paw, right? That's a pretty good hint that the question in question for question 3, that's going to be this. There's going to be something that involves having to make your own dice and then using random.choice to select what it is. Okay. The question on the exam will be harder in some ways and easier in other ways. So. Okay, so those are your 3 questions for the final exam. Okay. Your 3 questions are, again, read a file, censor information using regular expressions. Again, how do you don't have to use regular expressions, but the regular expressions will make it easier. How do you do that? Use re.sub, okay, to do that. That says given, and it says given a string, 5 all instances that match this regular expression. Replace it with this other thing. It's super useful. re.sub will do so much of the work for that one. Okay. Number 2, kind of a wild card, but I'm saying that it's something built into Python. It is probably something you've had experience with in other classes. But if you haven't, it's easy to understand and even easier to kind of see what we'll be doing with it. It will also be a file reading question because I like being able to use file reading. But it's going to be quite a bit easier. And number 3 is the Monte Carlo. And that will be more, and the Monte Carlo will be worth, is going to be worth 40 points. So it's going to be 30, 30, and 40. Monte Carlo being worth the most because that involves you having to basically create a system. Okay. And again, for the Monte Carlo, it's gave some students trouble last year because they decided to look up code for a board game. And it was for the wrong board game. And that got like 10 of my 100 plus students into trouble. Because not only did they not cite it, but they grabbed it for the wrong board game. And if you look on my syllabus, I explicitly saying not citing code and grabbing it and grabbing code that doesn't address the problem. E.g., you're trying to play Tetris, but instead you give me code for Puyo Puyo. Okay, then that's a good way to make me angry. Don't normally get angry. I'm a pretty chill guy usually. All right. So any other questions before we end the class? Yes.
I was gonna ask after class, can I screen share real fast? I have a technical question.
Sure. Let me go ahead and stop recording.